Okay. The next talk is Coding Confidently in Ruby by Maricris Nonato.
There you go. I apologize for that technical difficulty. So I'm not going to present my talk using Keynote where I started working on it before. So it's just going to be a PDF file. Anyway, I was prepared for this kind of problems, so I had it on Super as well. So pardon me for just staying here. So I'm Maricris. Good afternoon to all of the partners here. I'm welcoming you again to Boracay, so I hope you're having a good time. So I'm from Premier Speakers Bureau, and Premier is actually a company who helps you make your events successful and great by providing you an opportunity to book world-class speakers. So we're very proud of our speed and efficiency in our service, and we even accept last-minute bookings. So please do check us out if you want to invite like politicians and famous writers or whoever you know there out there who's gonna grace your events with really good motivational talks. Okay, so first off, I know all of us guys here are super duper awesome programmers. I mean, who isn't, right? Nobody's gonna confess to that. Oh, come on, not you, yeah, not you. So, my biggest rant is that we all write good code, but at some point in our lives, we still kind of second guess whether our code is really correct. Is it following the right set of best practices? Is it doing what it's supposed to do in the most optimal way? Does our code look elegant enough to be presented to anyone other than ourselves, other than our own pair of eyes? So we can sleep at night knowing that we wrote tests, our tests are all green, and everything's just happy, everyone's just happy, and you're sleeping like a baby at night. But it shouldn't really stop there. So I think that for us to become really good developers, we must be passionate with what we are doing. And for that to happen, you must first fall in love with your work. Like a sushi master would like to be very meticulous with how they cut their craft, so should we. So how do we intend to do that? How do we practice doing that? Well, first off, we really need to be always looking back at what we've started. It doesn't necessarily mean that this code written a month ago is going to be still the best code next month. Or say you learned something new today, you'd probably want to go back and refine those code, check it out again, and see if there's something else you can do. Or probably reuse Ruby 2.2.2. So, our code is actually a big storybook. For all the non-techy people, it's probably garbled words with semicolons, slashes, and whatnots. But to us, it's a story. We don't want our story to look like an adventure book. Like, do you want to enter the cave and fight the ogre? Go to page 332. So it's not supposed to be like that. It's supposed to be a very continuous, readable, scalable, maintainable code. It's something that's not just for you to consume. It's supposed to be for your entire team, and think about it as another piece of open source project. So the coverage of my talk is going to be divided into 3 sections. I have colored them quite beautifully, I think, into 3 different colors. So first, it's going to be about data inputs, then returning data, and then exceptions or error handling. So our code will always work, right? If you added some tests and you ran it and then it passed, then it's good, right? But what really destroys the quality of our code is actually the data. So if you have data, you should focus your attention on the data. Try to see how your code works around the data. Otherwise, it's really nothing. It's not significant enough. So, I love cats. I mean, who doesn't love cats? And the internet is full of cats. Commonly, we try to work around our code using conversions. So I know everyone's almost quite very familiar with this set of conversions, but I'd like to see a show of hands of who among you guys know the difference between explicit and implicit conversion? Oh, come on. You guys must be so shy. You're not in the video anyway, so don't be shy. So there's a difference between explicit and implicit conversion. The thing is, the implicit conversions marked on this table are only used internally by Ruby's core classes. And the explicit ones are the ones that we call in our code so that we can try to convert a class to another target class. For example, an integer to a string. You can convert it either using 2s or 2str. I'm going to explain a little bit more about that. So, I put some animations in my keynote presentation, but I'm afraid I'm just going to have to lay it all out like this. So here I'm going to demonstrate the difference between implicit and explicit. So say we have a class, cat. Oh, for brevity's sake, I did not put ellipses for all of the codes that I just clicked. So these are the only important parts of the code I want to demonstrate. So you have an initializer there, and I have a new cat instance. So when I do an implicit conversion, such as this first example, I'm using a plus operator. Unfortunately, if your class does not have an explicit toStr method, this is going to fail. That's why this is failing, because our cat class doesn't have toStr method. Now, we're going to try to use an explicit conversion. So we will call cat.toS. So the first thing that will happen is it will return like a hash of this cat instance because it doesn't know how to convert it. You see that it's not very effective if you use this kind of conversion in your code. Later on, I'm going to show some other examples relating to this, but we'll circle around that. The next one is about duck typing. Duck typing is probably one of the best features of Ruby. You don't necessarily have to know the kind of class that you want to work with, but as long as this object responds to something that you'd like it to do, then it should work fine. So this is an example of a duck. Quack your ducks if you have one. Oh, there you go. Thank you, Logica. So let's say you have your duck class and another duck recording class. So you can see that they both have a quack method, and if you call the make it quack, even if you pass either a duck instance or a duck recording instance, then it will sound a quack. However, there are cases where you'd like to extend the purpose of duck typing, and you can use respond to. The benefit of that is you don't really need to know every class that you have to work with. So in order to make it quack, in this case, I missed the slide. There, it's a slide. So assuming I'm adding a cow class here, and the cow doesn't quack, of course. So if we call animal that moo and it's checking against a cow, or the second version which is checking against a duck, this is not going to be optimal. What if you don't know how many animals you're looking at? What if you're looking at say 50 farm animals or something? So that's not very efficient. So the solution is actually to check whether this animal you're passing can respond to a quack method. Or the second solution, if you have a finite set of farm animals you'd like to make quack, then you could extend them by adding a sound off class and then just call animal sound off. Okay, sometimes you'd feel like your conversion methods are not very optimal. There are Ruby conversion functions which deals with these literals. All of them are actually present since Ruby 1.9, except for the hash literal, which was introduced in Ruby 2.0. So these conversions are actually much stricter, and this is an example of how they differ from each other. So you would probably want to use the conversion functions more for computations that are very complex, say relating to money computations, space computations, which are very reliant on precise math. So this is an example. The first column shows you that if you are given an input that is either a numeric value, either of an integer, a float, or even a string that can be converted to an integer value, then the integer function will give you the right output, I mean. But compared to the second column is actually the implicit version of a conversion to an integer. You can see there that it fails on several instances. The reason for that is the string inputs doesn't actually have an integer version of it. So it automatically fails. It's strict based only on the type of input, not on the expected output. And lastly, you would see that the explicit conversion dot to I doesn't even fail. The reason for that is a convenience method. So you should take note of that in your code. So when it doesn't know how to convert it, it will just give you 0. So it's not very accurate. So, but if it's not enough, then you can always make your own. So the first thing that you can do is create conversion methods for convenience. So for this example, assuming you're writing a map app, so you have this method called point label, and then I would like to call toLang if the point responds to that method. So it's more like making this conversion method for your own convenience, especially if your code will be peppered with these kinds of conversion instead of trying to repeatedly output location at for every time you call map point. So this coordinates just corresponds to Boracay, by the way. And then, furthermore, as I described the conversion function literals, you can also make your own. So assuming you're working on a Bitcoin-related application and you'd want to return money on wallet, you have peso and Bitcoin as your input. So the pseudocode is just to add the peso and the Bitcoin, right? So you have two attempts to make this elegant and probably more accurate. So you'd like to call peso that to float, convert it to float, same as Bitcoin. And just for sake of example, I'm trying to multiply Bitcoin by 1.5. I don't know if it's a good thing for the Bitcoin lovers. And then the second version is more like an extension of our learning earlier when we said that the Ruby conversion functions are more strict and more accurate. So we'll try to use that instead. So it's a capital float conversion, and then the same thing for Bitcoin. However, there's an even better code for that. Sorry. And what you can do is try to implement your own conversion function called peso. And the good thing about that is you can even wrap your own conversion method inside of it. So let's say you have this class Bitcoin, which has a value, and then you could create your conversion called 2 peso, wherein your capital peso conversion function can enforce a stricter conversion. So it would automatically reject the string and just return a float input. So it largely depends on how you need it, why you need it for, but know that you can do these things to make your code cleaner and probably function a lot better. And another thing about Ruby is we have nils. Yeah, who doesn't love nils? So your code works, but know that every other object in Ruby can be nil. A nil is a nil class. It can be empty or it can be absent. So if it can fail, it's probably going to fail. So you should anticipate it. That's bad. Anyway, so let's say we have this class person. Every person has a name and a birthday, of course. And assuming around that assumption, you have different methods like checking whether the person is a minor or returning the age. So every other method would be checking against the presence of a birth date. So you'll be doing these checks all over every time if you do not do the right thing, which is actually to set very restrictive way of setting a birth date, ensuring that every time you create a person class, you would have a birth date. So if you have this method here, then this is an example of how it will fail or it will be succeeding. So if you create a new person and you pass the wrong type of object, then it will automatically fail. And if you do pass the right object, then it gives you the right person instance. So what does that give us? It gives us the opportunity to rewrite our code into a neater version. At the bottom part, you will see that now our age method is cleaner and leaner, and surely it doesn't have to be peppered with a lot of if-elses, as well as our minor method. And another one that I'd like to introduce is power fetch. I don't know if you guys are familiar with this already, but this is another good revelation. So say we have this hash, foo and bar, and we're trying to well, some of the slides are missing. Anyway, well, fetch is a method of hash, and if you are trying to check the presence of a key from a hash, you would have to use hash key and then verify if this value is actually present, which is very tedious. So there is an ambiguity in that thing. So for example, we have this hash to work with, and I'm trying to get foo bar, the key foo bar. If you just call foo bar from direct inspect, you would find that it will return nil, right? But what if you're actually getting a key that has a value of nil? So it's quite ambiguous. You don't know whether the value is nil or the key is just not there. So the solution is actually to use fetch. If you fetch foo bar, then it will fail with an error. And the good thing about fetch is you could extend it to set the default value if it doesn't return a value, if it does not contain value, or if you could pass a block. Okay, this is probably my favorite. Everyone uses device or probably any form of authentication, right? And you got some dealings with current user object, and you already coded a lot of stuff that checks again current user, whether this object is actually referring to a logged-in user or not. So this would look very, very familiar. But this is just a small example. Imagine that you would have to check on current user for every action that you want to do on your code. So the solution is quite, it's not obvious. I didn't really think about it at the beginning, but I think this is a good solution though. So you could actually create a guest user. Doesn't have to work with your database, but it has to have all of the methods that your device user will be using, or those fields that your app will be referencing. So you would see here that the simple switch to return a new guest user object instead of checking it on every other method. So your greeting method would now look very lean and very elegant. So it's quite sexy. So again, circumventing around the presence of nil, there are ways to actually beat it. So if you have, again, let's say we have a person and then not everyone has a nickname, right? So who among you guys actually have your first names as your nicknames? I mean, my name is long enough, so I probably have one. But some of you might have a very short name, which is actually good enough as your nickname. So in forms, probably don't fill up the nicknames anymore. So if you don't, and we don't require this in our model, our render details would behave very badly. So the solution for that is actually to return some information that will save you from the error of nil, which is actually if you don't have a nickname, then you can just return your first name. So your method will no longer return an error. So you could probably think of putting in some values that will work for you, that's not going to destroy the function of your code. And there's also something you could do about passing data as inputs. Personally, I don't like seeing inputs in a method that's longer than 3. So ideally, you'd like to bundle them properly together. So one way that you can do that is, so if you take this blood class, it's obviously requiring coordinates, like 2 coordinates per line and 3 points per triangle. So what you can do with that is, it's going to be confusing very quickly if you have other data required by this class or these methods. So what you can do is actually abstract that information. So you can now create a point, which is a structure of 2 inputs, x and y. And then you can create a separate class line and triangle. And then you could pass an instance of line or the instance of a triangle to the draw line and the draw triangle method. So that way you could better express your code this way, and it's really readable, it's understandable, even by other people. I hope you agree. So the lesson here is we should be conservative in what we're sending, but be lenient in what you can accept, so that your code will be robust. So that's Postle's law. Now let's go to returning data. So there's this mathematical term called total functions. Total functions refer to functions wherein whatever you input into that code or to that function, it will always return the same kind of information. So I think in programming, this is a best practice that we'd like to put into habit. So an example is this search, which I deliberately messed up for showing you what I mean. So if you have a search function and then you're switching against the return, so this function will be returning either nil, a 0, or a result, or a set of results, which is kind of confusing, especially if you're meaning to make this an API. So let's take a look at this API as an example. So you can see here that it's returning an array. I mean, almost every API endpoint that I have seen will return an array, either empty or full of results. So that's how you should do it. Examine this example, which is the same method earlier. If you just cut it short like this, so that your result will always be an array of JSON objects. So this is going to look more awesome. It's easier to understand. You know outright what to do, so you'll just be bothered with converting your results to a JSON object. And then sometimes you have a code that just executes one if else or an unless else, but there's 2 sides of it, so it should be given equal importance. So, however, there are cases wherein you only want to do one part of it. So there's this graceful exit. So for example, you have this create profile method. So you just want to process this if the profile or the person is not banned. So the first instance, the one that's crossed out there, is doing unless at banned and then do something else. While that works, it's not the most awesome way to write it. So the better way of representing it is the one at the box. So you just outright return. It's a graceful exit out of that method. If the profile is banned, then just exit the method. You save the computing time. You save the programmer or the reader some amount of time understanding what's going on. And then the last part is about error handling. So most of us don't like to work with throws because it's more like a go-to, or it circulates around your code. But I think that it has its value compared to the more famous version of error handling, which is the rescue block. But you see that when you use throw, it saves you time from deep loops, and you could break out very easily. Compared to a break, a break is like a full stop. So throw catch will give you an opportunity to handle it properly, like exit with a good error message or something. So this is an example of how you can use throw and why it's good. So this is just a small piece of code that checks on 9 blocks of tiles on the floor and tries to figure out where your gummy candy fell on. So if you use a throw catch block here, then you would just spend 4 attempts on finding that candy. And you can even extend your throw to use a block. You could pass tile, or you could return a good error message. And then going now to the rescue block. Actually, you don't need a beginning and an end for that. This is the anatomy of the entire rescue block. So more often than not, we're inclined to type in begin rescue if we know that every statement inside can or might fail. So, for example, you have this quite buggy method, and you know that it's going to fail with every work that it's going to do. So automatically, you try to wrap it around a begin rescue block, which you can actually refactor to something nicer. So your first solution is actually to refactor, extract this begin rescue block into smaller blocks. And you can remove the begin and end. Just express it similarly as this. And this talk is actually greatly inspired by Confident Ruby from Abby Graham. But I also encourage you to read more on writing good code and working out your code way after your tests pass. So you could also read on Eloquent Ruby and Effective Ruby. So that's it. In the future, I'd like to know how you guys transform your code into a good story. So thank you for listening.